So today we're going to look at the polar and rectangular representation of a sine wave. So in polar form, we have the amplitude, and then we have the phase angle. Just simply write it like this. And in rectangular form, we have here, to find A and B, A is simply the amplitude times cos of the phase angle, and B is the amplitude times sine of the phase angle. Now we can see that these forms are equivalent if we have a look at the graph of the polar form, which is just a vector of length am at an angle theta from the positive x direction. Now if we break this vector up into its components using a right triangle, and we have A and B here, we can see that A equals AM times cos of theta, and that B equals AM times sine of theta. In rectangular form, we have J here. Now J is the complex number, the square root of -1. It makes more sense though if we think about it as the unit vector at an angle of 90 degrees. So here, J is rotating B counterclockwise 90 degrees from the positive x direction. If we look at this diagram here and we take tan of theta, we find theta equals tan inverse of B on A, and if we use Pythagoras here, we find that the amplitude equals the square root of A squared plus B squared. And these four equations here allow us to move between polar and rectangular form and vice versa. When in polar form, we're able to multiply and divide. So when multiplying two polar numbers together, you multiply the magnitudes and then you add the angles, giving us 6 angle 50. When dividing two polar numbers together, you divide the magnitudes and then you subtract the angles, giving us 3 angle 30. In rectangular form, you're able to add and you're able to subtract. When adding, you add the A's and then you add the B's, giving us 6 plus J, 9. When subtracting, you subtract the A's and then you subtract the B's, giving us 4 plus J, 3.